Today we're going to examine this particular question, and it's looking at wavelength. We're looking at specifically, we're looking at a transverse wave. We're looking at a transverse wave. And see, from left to right, you're going to notice that the actual frequency increases. Now let's look at the properties of this particular wave. We have radio wave, microwave, infrared, visible spectrum, the ultraviolet, the X-ray, and then the gamma. Now look at what the question is asking. The question is asking us, it says, which of the following statement best, let me underline because I'm going to use selective underlining, best describes the information found in the diagram from what? Left to right. So in addition to understanding the question, you also need to understand the directions, alright? It says from left to right. Let's go back up here and label. This is left and this is right. So I'm moving that particular way. What I need to find out now is my answer choices. Look at my answer choices. First one, it says as the wavelength increases, the frequency decreases. Well, let's come back to that one. That doesn't sound right. It says as wavelength increases, the frequency decreases. So look at this. If wavelength increase, right, that means it gets wider. That means it's saying that the frequency is going to decrease. Is that true? Okay, all right, let's move on. It says from left to right. Let's go down here to B. B says, as the wavelength increases, the frequency increases. So long wavelength leads to what? Low frequency. So we know that's incorrect. So we can cross that one out. Let's go down to the C. It says, as the wavelength decreases, frequency decreases. Now let's make sense of that. Wavelength is saying how close these areas are. So if they're closest together, that means it's saying that the frequency should increase. So we know that this is incorrect. Okay, now let's go down to the other one. This one says as the wavelength decreases, frequency increases. We have two things that we use. We use LL, not Cool J though, but LL, and then we have SH. We saying that LL saying that as the wavelength do what? Increases or get longer, then the frequency should what? Decrease. Wonderful. You're doing great. Stay with me now. Last one. Let's see why this is the correct answer. If we move up here, we're saying wavelength decreases. Look how far apart. Let's say I had this right here, and this was 5 centimeters, okay? And as I move over here, this may be, I mean, break these up into small pieces. This may be 1 centimeter. This may be another 1 centimeter. So what we're noticing as we go from left to right, that the actual centimeters actually decrease, which is going to be my wavelength. Again, when wavelength decreases, my frequency what? Increases, and that is absolutely correct. What we're saying now is that as you move from left to right, something should happen. Two things. One, the wavelength will decrease and the frequency should increase. That's the reason why choice D is our correct answer. Again, we talked about it quite a lot today, but I just want to come and explain to you what's going on here. Why D is our correct answer. We also use selective underlining because we want to make sure that when we do this, then it helps us to zoom in on the right question, to pick out those key things that we need to answer our question. So students need to understand that when you do use the selective underline, it leads you automatically to the right answer because you have to eliminate some of those things that you really don't need. Okay, so here, correct answer D. As wavelength decreases, frequency is going to increase. Again, this is Andrew Guy. Want to let you know we're just making science a little bit more practical. Take care. Have a good day.